Good day, everyone. Today we are going to be tackling organic chemistry by Dave Pugat. Oh, I am Dave, but I'm Dave too. So it seems. How about I call you Joe, and you get to call me Dave? Sounds alright? Well, alright. Good compromise. Well, carry on, Joe. Well, that got weird. Alright, so organic chemistry. So, what is organic chemistry? Organic chemistry started during the 1800s. Prior to it, they called it the vital force theory or vitalism, wherein chemists, people of science, believe that organic compounds only come from living things. These organic compounds are things such as sugar, um, urea, from urine, and the such. How it began. One of the starting points of organic chemistry came when John Jacob Berzelius has been going around and using the term organic to describe organic compounds coming from life. Then organic chemistry officially began when a German scientist, Friedrich Wohler, accidentally synthesized an organic compound. This is how it happened. He was planning to make ammonium cyanate by reacting cyanic acid with ammonia. But then after heating ammonium cyanate, he accidentally discovered that urea can be formed. Now note that cyanic acid and ammonia are inorganic compounds, and so is ammonium cyanate. But urea is an organic compound. Then this happening then disproved vitalism. So you're saying that we're studying organic chemistry now because they discovered that inorganic compounds can form organic compounds? Yes, that is correct. Well, now we study the reactions between organic compounds, so we would be able to utilize them to their best potential now that we know inorganic compounds can react to form organic compounds, because apparently organic compounds are present in many forms in our everyday lives. I'll give you some few examples here. Propane, we usually use them for our gas and cooking stoves. Butane too, for camping stoves. Alcohols, we use them as disinfectants, and sometimes they are also present in some beverages. Artificial food flavorings, these are esters, which enhance the odor and flavor of food. Acetone, which are ketones in an organic compound. We use them as nail polish remover. So now, what are organic compounds? I get it. So it would seem that there are many organic compounds present all around us, yet we don't even notice. Yes, Dave, that would be correct. So what are organic compounds? Well, apparently there are two types of organic compounds, hydrocarbons and hydrocarbon derivatives. What are hydrocarbons? Hydrocarbons are aliphatic. They can be saturated or unsaturated. Aliphatic meaning they are arranged in a manner such as an open chain of carbons. Now, this is an example of an aliphatic saturated hydrocarbon, meaning that all the carbon bonds only have single bonds present in them, and these are examples of unsaturated aliphatic open-chained hydrocarbons, ethene and ethine, which have double bonds, triple bonds. Now, another type of hydrocarbon are cyclic hydrocarbon. They can either be alicyclic, heterocyclic, or aromatic. Alicyclic hydrocarbons are hydrocarbons such as cyclohexane, which only have carbons and hydrogens in them. Heterocyclic hydrocarbons are hydrocarbons such as pyridine, which have, in this example, nitrogen present in the ring. But heterocyclic hydrocarbons can either have nitrogen, oxygen, or other elements in them in the ring. And aromatic hydrocarbons are special hydrocarbons which have the ability to resonate, having double bonds. And that was hydrocarbons. Now we move on to the hydrocarbon derivatives. Hydrocarbon derivatives. Let's call a blackboard here so that I can show you the different compounds. Now this is a hydrocarbon. It's a saturated aliphatic hydrocarbon, but if we knock off this hydrogen and replace it with a hydroxide, we get an alcohol, an aliphatic alcohol. And here, if we replace that, we get an aromatic alcohol, which is a phenol, a phenyl group attached to a hydroxyl group, a phenol. We also have aldehydes, which are carbonyl groups. You call this carbonyl attached to a hydrogen, and Dr represents a alkyl or aryl group, meaning it could either be saturated or an unsaturated hydrocarbon or an entirely different group. It could be a ring or anything else. We also have carboxylic acids, which are carbonyl groups bonded to hydroxyl groups. It's like having alcohols and aldehydes together, but instead of having hydrogen, you have hydroxyl here attached to an alkyl or aryl group. We also have ketones, which are carbon compounds, carbonyl compounds. This is a carbon, and this carbon is bonded to two aryl or alkyl groups. Then we also have ethers, which are two aryl or alkyl groups bonded to an oxygen atom. And we have esters, which are like plural of ethers having multiple oxygen. But instead of, remember carboxylic acids, instead of having oxygen bonded to hydrogen here, it is bonded now to a completely different alkyl or aryl group. So this functional group, oxygen double bonded to carbon and oxygen bonded to an alkyl or aryl group, make up esters. Now we also have thiols, which are aryl or alkyl groups bonded to sulfur and hydrogen. We also have nitrogen containing compounds. To cite some examples of these compounds, nitrogen containing compounds, we have amino acids present in chocolates. We also have urea, which are present in fertilizers. Other examples of organic chemistry all around us from the hydrocarbon group are propane from alkene. Yes, we use that for torches, fuel, for gas stoves. We also use ethene for alkene. From alkenes, ethene, also known as ethylene, has many products. Produce textile, paints, plastic bags, fur. It has many uses. Also, ethine or alkyne can be used in welding, fuel for welding. Ethine is also known as acetylene. Weird, right? Acetylene, even though it's alkyne. Now, organic chemistry around us. Hydrocarbon derivatives. In alcohols, we make use of ethanol. Under drubbing alcohol, we make use of formalin from aldehyde, which is a preservative. We use acetic acid, carboxylic acids, vinegar, also known as vinegar. Acetone from ketone can be used as paint thinners or nail polish removers. We use diethyl ether as anesthesia. These are obviously from ethers. We also make use of methyl butanoate as pineapple extract. It's an ester. Hydrogen sulfide. Thiols, it is an organic compound. Bad breath. Well, as we can see, organic chemistry really has many applications. Well, that concludes this presentation for now. See you. Well, thank you for that presentation, Joe. I sure did pick up a thing or two. I hope the viewers do too. Well, see you around.